Okay, so in this part we'll look at a couple of scripts, or a few scripts, but first I want to clarify one thing. Exit does stop execution of a script and does return a number. 0 is normally means success. It's also indicated to mean true, and we'll see that this is a little bit of a problem because in other situations 0 is considered false, so it's a little bit of a awkward thing to deal with. But for exit, 0 almost always means true, or means the program worked. Anything non-zero, positive or negative, other than 0 means fail, or something went wrong, or false. One thing you want to watch out for is that if you use exit in a script, let's say you wrote a very simple script, right? And all it had was these two lines, one saying that this is a bash script, and the only line of code is really to exit. Well, if you run this the way you want to run all the scripts in the lab, the way I would like to see everyone run scripts, is to have this first line, this comment that says the interpreter for this program is /bin/bash, and then you make this script executable. Then you can run it like this, /, let's say you called it stop script. Then this program doesn't do anything. All it does is it starts up and bash says the first line of code is exit, so I stop. Even if you have lines of code after this, nothing happens. It just ends the script right there. Okay, so that's fine. That works exactly like it was intended. You can put in exit 0 or exit 1, any number you want, and it doesn't really matter so much because it's the only line of code and you're not going to use it for anything else. Okay, so that's good. But here's the problem. If you set up the script to not be executable and you use either source or the command space name of this file, what happens is this entire shell is quit, because this exit, what it does is basically it says, okay, I want to take all the commands. What the source operator does is take all the commands in here and run it in the current script. And so as a result, what happens is that you exit out of the shell if you use this source command. So another thing to watch out for, another good reason to use this first line of code to indicate that you're supposed to run this as an executable, and that the interpreter for this program is /bin/bash. And then you make this file, let's say you call it stop script, you make it executable, and you run it like this. Alright, so another good reason to run scripts using this rather than the source or the command. So I would say try it out, see how things work. I think it'll make sense that this is the way you want to run scripts. Okay, so the next thing we will look at, if then else, works pretty much just like any programming language. So in that way, it's pretty straightforward. The only thing that that is a little bit kind of strange is the syntax. So you have to have if, and normally people use the open square bracket, and you have your Boolean condition here. The thing is, Bash is very picky about the syntax that you put over here, and then there's very little, since this is an interpreted language, there's very little feedback as to whether you did something wrong or not. You don't find out till you run it. Okay, so I'll try to go over a few scripts that show you how to use if statements, loops, and just do it very quickly in this video, and then maybe come back to it in more detail later. Okay, so first let's review some of the scripts that we've set up so far. I have a bunch of them here. If I cat the very simplest one, oops. Okay, so this was the very first script that we saw. What this script is doing is, if the first argument to this script is a file, then it will read in one string and print it out. So let's try this out. And I have a data file here. So okay, so if I cat this data file, oops, it has 2 lines, and what happens is first bash checks if this parameter or argument is a simple file, and actually it is. It's just a simple file. If it is, then it will read 1 line from that file. So the $1 refers to that first argument. And the read command just reads in 1 line and reads it from this file into this variable x and prints out the variable x. That's why we get this first line when we run the program. Okay, so if you can try this out, change the data, and then you will see that whatever gets printed out will change if you make changes in the first line of this input file. All right, that's fine. So that's a simple if statement, and there's many things, many conditions that you check in here that are based on files. A lot of them are based on files, and there's also stuff for numbers, checking if i is equal to 1 or whatever. And we'll go over some of that, but not just yet. Let's just take a look at some of the other scripts that we've tried so far. I'm just reviewing things that we've done. What did I do? 02. Okay, so here is another example of using these special characters, these \b. So this will print out hello and then a space, and then it'll do 1, 2, 3, 4, 5 back spaces, and then it will print a carriage return. Carriage return means you go all the way back to the beginning, and then you say goodbye, a new line, and then the 07 is the bell. So let's see if this works. Okay, so it did work. Everything worked as it should. I didn't hear a bell, but it might just be because of my speaker. I think it's been disabled. So if you're working on a system that has a speaker, you should hear the bell when you do this character. So once again, let's try that again. The carriage return, and what you can do is put in this script and move things around, change it around. The carriage return, what it does is go back to the beginning of the line but stays on the same line. It's different from the line feed or the new line character, which goes back to the beginning of the line and goes down 1 line. So that /n goes down, /r stays on the same line. Okay, let's take a look at another one. Okay, so this script is just showing you that you can assign 5 to a variable x, print it out, and then you can assign string x, the string value hello to x, and then print it out. So let's just try that. Turns out that actually all variables only hold strings. It's just that you can interpret them as numbers if you wish. So actually, these two things are really doing the same thing. This is storing the string 5 into x. This is storing the string hello into x, and it looks like this is the number. It just so happens that we can write other commands that interpret x as a number or as a string. So there we go. First case, when you print out x, it's 5. Second case, it looks like something completely different, that is a string. Okay, so let's cat the next one. Now in this case, I'm looking at a whole bunch of built-in variables. Remember, $0 is the first argument, basically the name of the program. So in this case it will be exactly this, or however you call this program. So if you call this program using dot slash and then the name of the file, you'll get the whole thing, dot slash lec11 -04.sh. So this line will print out exactly this. Then it will look for the first argument. I'm going to give it a bunch of arguments, x, y, z, a. How's that? So this $1 should print out the x. The dollar number will print out the number of arguments, not counting the program name, so it should print out 1, 2, 3, 4. This next thing is just an empty line, so it'll print an empty line. Dollar @ is all of the arguments as an array, and the $* is all of the arguments, this time as one string. And it won't look different. These two will print out the same way. $$ is the process ID of this script when it runs. And $- is just a built-in variable that's set to lowercase h, uppercase b for scripts. And it's something else for interactive shells. Okay, so let's try this out. There's the output. Sure enough, here is the name of this script, or the 0th command line argument, which is just the name of the program. Here's the first argument. The x came from here. The 4 refers to the 4 arguments, 1, 2, 3, 4. This prints out all the arguments as an array. This prints it out as a string. You see the same thing. So the point of this is just for you to try out these variables. Remember, we're not defining anything. These are all built-in. These are all built-in variables. Why are we doing this? So that we can format our printing. So we're just saying, don't treat this dollar as it's usually interpreted as, the name of a variable. Use this, just print out the $, then just print out the @ Here it's treated as the variable name. Okay, so you'll see the process ID. Does that make sense? Sure. If you say PS, you will see that the process ID of this PS was 3435, and it makes sense that the previous command was 3434. So when we ran this command, the process ID of that command was 3434. The very next command got the number 3435. Makes sense. HB, this is the standard value that this variable has, $- in all scripts. In any script, you should see this value for $-. Alright, so there are some other scripts in here. I'm going to cat them out. Okay. So here is an interesting one. You print out echo with a -n option. That means once you print this out, don't go on to the next line. This is so that the user can see this and print something, or type something on the same line. So if you run this, /lec11.05.sh. So there it goes. So it prints it out and doesn't go on to the next line. That's what the -n does. Now it's waiting for me to type in something, and it will read in my answer into this variable. Then it'll check if my answer is uppercase Y or lowercase y. If it's either one of those, it says thanks, else it prints out an angry message. So I'll say N. There you go. Let's try it one more time. This time I'll say Y, and it works. So that's your basic if statement. Does this cover all of if statements? No. There's hundreds of thousands of things that you could do with if statements, and this is just the very, very beginning. We're just looking at very basic use of if statements. We will see more of this pretty soon.